The second type of domain was the restricted domain. Now, what is a restricted domain? It is basically the subset of the maximal domain. Okay, that means it is any portion or any part from the maximal domain. Now, what happens is the examiner can give us any portion of the maximal domain, that is the restricted domain, and can ask us about the range of the function. Okay, now how would we find the range of the function? So for the range of the function, always the key trick is to always find out the minimum and maximum value of the function in the given domain. That is number one. Number two, if you remember the definition of the range that we discussed in the last video, it is basically the set of values of y of a relation, and we are dealing with all the relations that are functions. So in other words, I can say the set of values of y of a function. So make sure all the set of values of y should be defined by the range of a function. Okay, so there are two key points. I'm going to repeat them. First one, range should define all the set of values of y in a function. That's what I'm going to write it down over here as well. So the range should define all these set of values of y in the given domain. Okay, and point number two was, which is mentioned over here, that the key trick is how would you find the range? Always find out the minimum and maximum value of the function in that given domain. Alright, now let's have a look with the help of an example that how would we actually implement that knowledge in the questions and how would we solve the questions. Okay, so let's jump on to the example number one. Now in this example number one, the function f of x is defined by (3x plus 2) for the given domain x is greater than or equal to -2 and less than or equal to 5. Now the examiner says, the question is, find the range of the function. Now again, recall those two concepts that we have studied. In order to find the range of the function, there were only two things, and I will always be using these two concepts in order to find the range of any function. It doesn't matter if I'm doing a piecewise function or a trigonometric function, or I'm doing a algebraic function, exponential function, whatsoever it is. For all the functions, whenever you have to find out the range of the function, you have to remember only these two concepts. The first one is the range should define all the set of y values. Second thing, again the trick is you'll find out the minimum and the maximum possible value of y in that given domain, and that would basically provide us the range of the function. Okay, let's have a look. Now just to give you guys the idea, y equals to 3x plus 2 is a straight line because it's a linear equation and it has a positive gradient. That means it's going to be just like this with the y-intercept of 2, right? It's just a rough sketch so that it provides you guys the idea of how to find the range. Now I can see the given domain over here is, have a look here, it is from -2 to -5. If I would have to find the maximal domain, the maximal domain for this function would have been all the real values, right? If you remember the definition of maximal domain, it was all the set of values of x for which the function is defined. Now because this is a linear equation, we can see that this function will be defined for all the values of x. So the maximal domain would have been all the real values, but what the examiner has done over here, he has provided us just the portion or a part of maximal domain, right? Now again, I'll think about the same concept, that what is the minimum value and what is the maximum value of the function in this given domain. So -2 would lie somewhere here, and x equals to 5 would lie somewhere here, right? So let's have a look. What is the value of x at -2? What is the value of y at -2, and what is the value of y, or in other words, what is the value of function at +5? Now why am I doing it? That is because, remember what I said, the range will always be determined by if we find out the minimum and maximum possible value of the function in that given domain. Okay, so that's what I'm gonna do. Now basically I have to find out f of -2, that what is the value of function at x equals to -2. So I'm gonna replace all the x in the function by -2, and this would turn out to be -6 plus 2, and that is equivalent to -4. That means f of -2 is equal to -4. So the value of function at x equals to -2 is -4. I'm just going to label that over here as well. Now let's find out the maximum value of the function. So that would be at x equals to 5. What is the value of the function? So I'm going to replace x with 5, and it is going to be 17. So the value of the function at x equals to 5 is 17, right? Now again, have a look here. What I have done, because I can see it's a linear graph, and when I sketch the shape of the graph, just to have the idea of what can be the range of the function, I got to know that the minimum and maximum value of the function would lie at the extreme values of x that are provided in the domain. Okay, that is why for the very first time I plugged in the value of x as -2 to get the minimum value of the function, and then I plugged in or substituted the value of x as 5 to get the maximum value of the function, right? So I do have the maximum value of the function in that given domain. I do have the minimum value of the function in that given domain. So what would be the range? The range would be y is greater than equal to -4 and less than equal to 17. So this is the range of the function. In this example number 2, the function f of x is defined by x squared minus 2 for the domain x is greater than equal to -2 and less than equal to 2. And we have to find the range of the function again. So because the question involves the range of the function, again we will jump back onto the same concepts that we discussed. Whenever we have to find the range of the function, again I would always think of those two concepts. The first one was the range is the set of y values of the relation, right? So all the y values should be covered in that range. Second thing, the key trick was what we will do, we will always find out the minimum and maximum possible value of the function. Okay, so let's start off. Now I can see, because it's a quadratic equation, that means it should be the graph should be a parabola. I'm just gonna redraw it. And what would be the y-intercept? I can see that over here, that if I substitute x equals to 0, the y-intercept would be at -2. And that is basically, in this scenario, the minimum point of the function as well. Okay, now how do I know this is the minimum point of the function? Because if you remember, for the quadratic equations, if it is a parabola, Just giving an example. Now if it is a function x square, that means it would always be a parabola with, or a u-shaped graph with the minimum point as, or the vertex at 0 0, right? And if we add subtract anything to the function itself, the function will be translated in the y direction. If we are subtracting anything, that means it will be translated in the negative y direction. If we are adding anything, that means it will be translating to the in the positive y direction. Okay, so because we were subtracting 2 right now, that means the graph would be translated in the negative y direction. And how many units? Because we are subtracting 2, so it should be 2 units translated towards the negative y direction. So the vertex which was initially at 0 0, now that was translated in the negative y direction, and that is why it is now at -2. So the coordinates would be 0 and -2. Okay, this is what I have shown over here. Anyways, so because we have to find out the range of the function, we will again find out the maximum possible value of the function and the minimum possible value of the function. Okay, so let's find out the maximum possible value of the function first. So if a graph is parabola, one more important concept, we do know that it has only one line of symmetry. Okay, and what would be that line of symmetry? It will be always on the vertex. If we cut the vertex parallel to y-axis, it will always divide the graph in 2 equal portions so that it can be folded onto one another. Okay, so that is basically the concept of line of symmetry as well. And for this graph, we can see the line of symmetry is this one, the y-axis itself. Ready? So why I'm saying this is because at -2 and +2, let's say this is -2 and this is +2, the y value would be same. All right, so always for the parabola, if the distance from the line of symmetry is equal, the y value would always be equal. So let's find out the maximum possible value of the function. So what I would do is I will substitute 2 or -2, it doesn't matter, and I will find out the maximum possible value of the function. So it's going to be 2 square minus 2, and if I solve it out, it is going to be 4 minus 2, that is equivalent to 2. So the y value over here is 2. That means the maximum possible value of the function is 2. And what is the minimum possible value? If you remember in the last example, what we have done, we substituted the minimum possible value of x to get the minimum possible value of y, and maximum possible value of x to get the maximum possible value of the y, right? But that is not the case in every situation. Okay, that is why I'm doing this example. Remember, we have to stick to the concept that we have to find out the minimum possible value of the function and the maximum possible value of the function in that given domain. Now, because for this domain, the maximum possible value is 2, we can see that, but the minimum possible value is over here. Alrighty, that means the minimum possible value of the function is lying at x equals to 0, and that is -2. Now, even if we do not state that it is lying on x equals to 0, that is fine. We should know that the minimum possible value in this case is -2. So I'm just gonna say minimum value of f of x is equal to -2. Alrighty, I can also say that this as minimum value of f of x, or at, in fact, let me do this again. So minimum value of the function at x equals to 0 is equals to -2. So both the statements means the same. Okay, now I have found out the maximum possible value of the function, that was +2. I have found out the minimum possible value of the function, that was -2. So what would be the range? the range would be y is greater than equal to -2 and less than equals to +2. So this would be the range of the function.